Please welcome to our first team for Team 17 from Jinwon High School. They are going to present Equal Age, Equal Friendly School.
Good evening, ladies and gentlemen and students. Today we are honored to be here to present our topic, Equal Edge, the eco-friendly school of tomorrow. As the world facing climate challenges, we believe school can lead us toward a more sustainable future. Equal Edge brings together community and nature to present a more sustainable future. And today we'll also talk about some potential challenges and the solutions to address them. And these are our philosophies: to sustain, recycle, and to conserve. And now let's move on to our first topic, building materials.
Self-healing cement is an incredibly durable kind of cement, and it heals its own cracks, so that reduces repair costs significantly. Since it heals its own cracks, you don't need to produce new cement to replace the old damaged cement, cutting CO2 emissions. As soon as water comes to contact with the cracks of the self-healing cement, it triggers bacteria to seal up the cracks, preventing corrosion. Based on these 3 points, it's very self-sufficient. That's why we chose it, because it aligns with our philosophy of sustainability. However, it has a really high initial cost, and during the production of self-healing cement, a lot of CO2 is released. Despite its high initial cost, it's actually cheaper in the long run because it tremendously cuts repair costs, ultimately paying for itself over time. To deal with the carbon footprint produced within the process, we will use recycled industrial byproducts such as fly ash or slag to further decrease carbon emissions. We will also replace a lot of calcium cement with magnesium cement because you require less energy to produce magnesium cement compared to calcium cement. And less energy means less CO2 emissions. And some forms of magnesium self-healing cement, when it heals its cracks, it can actually absorb CO2 within its vicinity, making it carbon negative. Magnesium cement is also more durable, maintaining the structural integrity of our building.
And I'm talking about permeable bricks. So it is a paving material that has many tiny holes in it, so water can pass through it easily. And it can help to provide flooding and filtering water and refilling groundwater. Also cool the environment by evaporation. And even though it still has some drawbacks, like weeds and plants may grow up near the holes and to affect the function. And it is not able to function in extreme weather. It might break or something else. And can endure a heavy weight. So how do we fix that? We have furniture, fabric, textile to underneath the brick and to block the weeds growth, and we can rely on natural predators to control the pest without chemicals. And that's all. And
Piezoelectric force turning movement, like your footsteps, into energy. So it does not require external power sources, cutting our energy bills. It's also eco-friendly because using piezoelectric force energy, it decreases our reliance on fossil fuels or firepower, contributing to a greener environment. Since it has no mechanical moving parts, it is less prone to mechanical failure, resulting in very low maintenance and an extremely long lifespan. We will also integrate a smart IoT system to our piezoelectric force. Now I would like for you guys to take a look at this model of ours. The piezoelectric force will be built underneath these main driveways as well as this basketball court, since there is a lot of traffic, so it generates energy. However, the energy generated by piezoelectric force per footstep is really small, and large foot traffic is required to generate a meaningful amount of energy. That's why we use piezoelectric force mainly to power smaller devices, like these small devices, as well as solar sensors and viewpoint sensors mentioned later. instead of using piezoelectric force energy immediately, we will also store them, accumulate them over time in lithium-ion batteries or supercapacitors, so that in the future, if there's an earthquake, there's a power outage, we can harvest the piezoelectric force stored energy for emergency use.
Have you ever felt uncomfortable because of the intense sunlight shining through the window? Well, this is a device that can totally solve this problem. When the sensors beside the smart glass detect sunlight, it will let the chemicals inside the glass turn black. So it can totally block the UV and IR to protect for people and furniture. And the benefits, it can reduce carbon footprints because of the decreasing the usage of AC synthetics. And the disadvantages. Most types of smart glass usually cost electricity. So to fix that, we can use other types like passive smart glass or liquid crystal smart glass. And as for the constant electricity, we have energy from piezoelectric flows.
Now I'd like to introduce the heating and cooling. First up is our chill beam system. So basically how it works is metal pipes are installed on the ceiling and cool water flows through these metal pipes, cooling the room down. It also creates a natural circulation by cooling the air on the top to make it thin so that it falls down. And these water, the water that flows through these metal pipes can actually absorb infrared radiation emitted by objects inside the room. When it leaves the room, it takes away the infrared radiation with the cooling the room down. It does not require mechanical air movement like motors of fans turning around, making it less prone to mechanical damage, ensuring its long-term efficiency. It is also really effective compared to fans because water is way more effective at carrying away heat than air is. And unlike fans that blow dust and air just around, chill beam systems don't. It's also a quieter operation, letting the students in the room feel better. However, water droplets might condense on the cold surface of the chill beams, and molds might grow on them, so we will fix that. First, we will use dew-point sensors. These sensors trigger an alarm when a condensation risk is detected. We will also use water-repellent materials to coat on the chill beams. And we will set the water temperature cold enough to cool down the room temperature, but not so cold that it falls below the dew point of that room, further eliminating condensation risks. Furthermore, we will integrate a smart climate control system to the entire system. Now it's time for our aquaponics system. So our aquaponics system consists of three main parts: a fish tank, a bacteria tank, and a plant bed. The fish tank, when the fish lives, it produces waste. The wastewater is harmful to the fish, so we pump the fish tank's water filled with waste to the bacteria tank. The fish tank's waste is ammonia. The bacteria eat the ammonia to live and produce nitrites. These nitrite-filled water is then pumped to the plant bed, where the plant eats the nitrites to survive and leaves the water clean again. The clean water is then pumped back to the fish tank so the fish can live happy. The fish and the plant and the vegetables, fruits grown under the plant bed can provide the students as food sources, cutting our food budget. And when the temperatures in this building exceeds a peak temperature, if it's too hot, the circulation of water inside this aquaponics system will actually go through the chill beams installed in the building, further cooling the buildings down. Take a look at these small huts. These small wooden huts are worm beds and fly farms. Children's food waste will be fed to these worm and fly farms. The worms and flies eat these food waste, converting them to organic fertilizers. We give the organic fertilizers to the plant beds. Worms themselves, as well as fly eggs, will be food for the fish tank. We also have seed recycling bins installed in every classroom, so we collect seeds of fruit from children's lunch and regrow them on the plant bed. This ensures a really self-sustaining and low-budget system. However, the organisms living in all tanks can be sensitive to temperature. If it's too hot, they might die out. And the nitrites, as well as the ammonia, might clog up in the pipes, so we certainly have to fix that. Now, how are we going to ensure that the fish tank's water is suitable for the fish to survive? Here is a simple visual demonstration. Imagine this is the fish tank. Underneath this is the ground. These two, as well as these two coils, are pipes. Inside the pipes, you store water in them. Let's say the fish tank is really hot. The water stored in these coiled pipes also gets hot. But the water stored in the underground level is cool because it matches the underground temperature. We pump the hot water down and we pump the cold groundwater up. The groundwater continues to flow through these pipes, cooling the fish tank. And the hot water from the fish tank also flows through the underground loops. When it flows through underground loops, it actually matches its temperature with the underground, ensuring that in the future, if the fish tank is still hot, we can still pump cold water to cool it down. We also implement solar, perovskite solar cells as well as sand batteries to heat the fish tank if it's too hot. We have automated temperature monitoring systems and effective filtration systems in the pipes to prevent clogging. Our third system is the aquifer system. Imagine it's a hot summer day and you really need the buildings to cool down. What we do is we extract groundwater. The groundwater is relatively cool and it circulates through the pipes in the building, taking away heat, letting the building cool down. But the water itself absorbs heat, so it turns hot. This is stored in the hot reservoir. In the winter, where we need the buildings to get warm again, we extract water from the hot reservoir, pump them through the buildings, making the buildings hotter, and it itself gets colder. Then we store the water in the cold reservoir to use it to cool some hot summer buildings. This all will be managed with advanced building management systems, and it is really sustainable. To show you that this smart aquifer system actually works, renowned as the world's smartest building, The Edge in Amsterdam, has actually implemented such a smart aquifer system like ours, and it has reduced overall energy consumption up to 70%. However, when you extract groundwater from the ground, it might cause land subsidence, and farms and factory wastewaters might get mixed in our system. But actually, our school does not have to worry that much about land subsidence because we have all these grasslands as well as permeable bricks that allow constant groundwater recharge. But that's not all we're going to do. We're also going to constantly regulate and monitor the groundwater level. Moreover, we will establish protected zones around major aquifer recharge places to effectively trap oil droplets and wastewater. We will also dig groundwater monitoring wells so that children in the school can constantly collect samples of water to detect for pollutants. We'll also implement a real-time tracking system to track for pollutants.
Now I will talk about the energy source and the storage of our school. So, the STEM batteries are the main point of our school buildings, and when they're placed on the ground, they don't have much problem. But when they're placed under the ground, they come with both advantages and disadvantages. The advantages are that the ground is the natural insulator. However, moreover, it can also protect from weathering and other rain damages. However, as you can see here, they're placed under the ground, so a lot of land needs to be excavated. Moreover, the heat exchanger may become less accessible for the maintenance. And lastly, swamp stability can affect so much to the STEM batteries. So to solve that, we're going to implement automatic drilling system to cut off labor costs. And we're going to install automatic monitoring system to ensure that our heat exchangers are working well. And lastly, we're going to have geotechnical analysis before the installation of STEM batteries to ensure that the ground is safe. Now moving on to the perovskite solar cells. So the perovskite solar cells are really effective and very versatile. However, they come with a few challenges. They're currently not readily available and there are currently no best technology on the market. And moreover, they are really sensitive to heat and UV light. So to solve that, we're going to collaborate with different tech companies who would like to test out their solar panels, and we can have a win-win situation. And secondly, we're going to use vacuum thermal evaporation on top of spin coating method to ensure that the layers are perfectly thick and uniform. And lastly, we're going to use advanced encapsulation method with 2D perovskites to ensure that these layers are protected well from the damages.
Talking about water waste management and also reservation and recycling. So first, we can save our costs by reusing rainwater. And second, we can decrease our environmental impact by reduces the school reliance on potable water. Third, students can learn water management through the systems in the school. And fourth, the stormwater collected by the permeable bricks can help keeping the school ground safe. Drawbacks and solutions, like the water might evaporate through the sunlight and sediment accumulation. It may let the water quality get worse. And seepage loss. The water underground may leak out to somewhere we can collect it. And so how do we fix that? We have floating solar panels and covers to decrease the evaporation. And for the sediment accumulation, we have dredging control, flushing, and bypass systems to increase the water quality. And for the seepage loss, we have clay and geomembranes or biosealing methods to keep the water in a certain area. Now let's talk about the school structure.
So this is to give you a brief explanation on our design choices. And as you can see here, our school buildings are mainly curved to receive as much sunlight as possible. And these two buildings are higher than this building to ensure that no shadows are casting upon these buildings to make the most out of our solar panels. Moreover, as you can see here, there's a lot of green areas which encourage students for the movement as well as exercise, which improves both their mental health and their studies.
So by piezoelectric floors and smart glass, we reach our goal to sustain. And the aquaponics system, which our goal to recycle as much as possible. And the permeable bricks and aquifer system let us to conserve as much as possible. And in this way, we really align ourselves with our philosophy. And these are our resources now. Thank you, everyone.
I love the high-tech knowledge slides. So any questions for our judges? I'm so impressed, but I have to admit I'm kind of lost in the way because we're professionals.
Okay, thank you very much for your presentation, and your school building is really fantastic. Just one question, how did you find because you mentioned some drawbacks and solutions, how did you find solutions to those drawbacks? Did you actually do some experiment, or you just did some research online?
We did researches regarding to those matters because they're quite actually common in the buildings that actually use these systems. So we did an extensive research, mainly from NDPI research paper websites, and we read quite a lot of those and choose a few best solutions to solve those
So
problems.
basically, we stood on the shoulders of giants. We studied like a lot of buildings actually implement these systems, and there are actually issues that these buildings face. And there are already a lot of technicians that have come up with brilliant ideas to effectively solve these matters. Thank you.
Another questions?
Well, first of all, I really appreciate how you guys address advantages, disadvantages, because it makes your decision-making process so clear. So we know what you're choosing and why. So I think think that's a really, really strong feature of your presentation. For some of this, I think, just judging by our reactions, you can kind of tell a lot of your materials are very cutting edge, very new.
Yeah.
And then, for me, I wonder, do we have manufacturers? Do we have this? Is this all available, or are these prototype types of technology?
Well, actually, a lot of our aquaponics systems and that they're actually already available, and a lot of buildings actually use it. Like in Japan and England, there are already pavements with piezoelectric floors underneath them that generate electricity through traffic to power the light poles around them. And the chill beam system, we mentioned it as well. The edge in Amsterdam has actually implemented, saving a lot of energy.
And permeable bricks, it is actually available just in Taipei.
Really?
Yes, it's at the toppest floor of 101 Tower. And the toppest floor of 101 Tower actually implements permeable bricks. And the toppest floor, it has one toilet, and that toilet actually uses the water collected from the permeable bricks from its toppest floor. Yes.
Fantastic.
Our previous mayor also has a plan to implement as much permeable bricks as possible, making Taipei like a sponge city that does water conservation. Yeah.
Yes.
Thank you.
Thank you.
Thank you.
I have a lot of questions.
Can you hear me? Okay. Fantastic. I really like this school. And the design is not only eco-friendly, it also create a lot of green space for students. And I find you also have divided into high school, vocational, and middle school. And I have a very important question because you want to build this. I want to know how much you need to spend for create this school.
To be entirely honest, it will cost the maximum. It will be around 2 millions. We did calculations.
Pounds or NTD?
Uh,
Pounds.
Yeah, pounds.
But as you can see, our school actually has a lot of self-sustaining systems, reducing maintenance costs in almost every point we mentioned. So it actually pays for itself over time. So it might turn out to be even cheaper than conventional schools because of how much repair cost it cuts down.
Okay, you're hired. Come to build a campus in Sheffield, please.
And to actually collect the funds, this part of our school is actually a public access area. So the public can access into this area and learn about the aquarium and the bacterial farms with one entrance per $15 per person for the educational vacation in our school.
The aquarium is basically the fish tank. We chose to call it an aquarium because it sounds better and it's actually cooler to have. The students can walk past it and view and admire it. Yeah.
Yes, and they can also have marine biology experiment for more top of course, and do some experiments in our aquarium systems.